In a problem like this, you want to make sure you understand the instructions. They say write an equation for the line containing the given point, talking about this point, and they must be parallel to the given equation or the given line. So we want a line that's parallel to this one. Right away, I know that parallel lines must have equal slopes. So my slope of the new line is going to be 5. How did I know that? The slope of this line is 5. Therefore, I want my new line to have a slope of 5 because it must be parallel. And it's got to contain this point. When I have a point and I have a slope, I always write it into point-slope form. What is point-slope form? It's the same as y minus y1 is equal to mx minus x1. And we use that to plug in our values and get our equation. So we know here that this is x1 and y1. And we know our m here, so let's plug those values in. We have y minus y1, which is 7, is equal to our slope, which is 5, x minus x1, which is x1 is 0. Okay, now I have my equation that looks like this, but that's in point-slope form. I want to get it down to look like y equals mx plus b. So I start off by distributing. So I have y minus 7 is equal to 5x. 5 times x gives me 5x. 5 times 0 gives me 0, so I don't really have to put anything there. It would be the same as putting plus 0, but there's no point for that. So let's get rid of that. Now all I do here is isolate my variable, so I add 7 to both sides. That's gone. I end up with y is equal to 5x plus 7. Notice here they have the same slopes. So this is my answer. Now, one thing I do want to point out to you guys. Notice they look very similar. This one's y equals 5x minus 7. This one's y equals 5x plus 7. Parallel lines must always have the same slopes. Now, if this would have been a plus 7 and this one was a plus 7, they would actually be the same equation or the same line. But in this case, they have different y-intercepts. This one starts at 7, this one starts at -7. So they are different lines, and they are parallel because they have the same slope.